Hello students, good morning. Today again we can continue the lesson 1. In the lesson 1 from the video 1a we have seen the introduction about metallurgy. What is called as metallurgy? What is the purpose of metallurgy in chemistry? And what are the techniques employed in the metallurgy? Okay, so this already we have seen in the metallurgical processes there are 3 steps followed. What are they? The first one is concentration of the ore, second one is extraction of crude metal, and the third process is refining of crude metal. About this I have explained in the previous video itself. What is called as concentration of the ore? The removal of impurities associated with the ore is called concentration. Then what is called as extraction? Here the purified ore will be converted into the metal. Okay. Then what is called as refining? The extracted crude metal will be associated with some impurities. So the removal of such impurities from the extracted metal is called as refining of crude metal. Now in this video what we are going to learn is we are going to discuss about the various concentration processes employed in the metallurgical steps. Okay students, this also already we have seen in the previous video. Again I am just reminding you concentration of the ore. Okay, so what is called as concentration? The removal process of gangue from the ore is called as concentration. What is gangue? The non-metallic impurities, the rocky materials and the siliceous matter associated with the ore are called as gangue. So the removal of this gangue from the ore is called as concentration, and these are the processes given in your textbook which are used for the concentration of the ore. What are they? The first one is gravity separation, second one is froth flotation, third one is leaching. Leaching is of various types: acid leaching, alkali leaching, ammonia leaching and cyanide leaching. Then finally the fourth concentration technique is magnetic separation. Now we can see these techniques one by one. Okay students, let us discuss the most important and the most easiest technique used for the concentration of ore, that is gravity separation. Okay, well students, this method, gravity separation method, it is based on the term specific gravity, or simply we can say it is based on density. Dear students, in the village sites we might have seen about winnowing na thootrudal. Okay, the rice associated with the rice husk, it will be winnowed from a height. So during that time the lighter husk particles will be drawn away by the flowing air. Have we seen? Yes. In the same way this method is also used for the removal of the impurities which are lighter than the ore particles, which means the impurities will be lighter whereas the ore particles will be heavier or denser. Okay, so here the essential criteria to follow this method is the ore and the gangue particle must have different specific gravities. The ore must possess high specific gravity whereas the gangue particles should possess low specific gravity. So this is the most important criteria for a ore to be concentrated using gravity separation method. Is it clear students? The ore associated with gangue, ore should have high specific gravity, which means it should have high density, whereas the gangue should have low specific gravity or low density. Okay, okay. Now this is the diagram of gravity separation method I have drawn at the bottom. This is the diagram of gravity separation method. Okay, so look at this picture students. Here what we have taken is the finely powdered and crushed ore. It is allowed to fall along with the running flow of water. This is running flow of water. This is the powdered form of the ore. Okay, so when the powdered form of the ore is allowed to flow with this running flow of water, we have seen in the we have seen just now the gangue particles are lighter in nature, so they are washed away. So this is the gangue particles. Since they are lighter, they are washed away by this running flow of water. And the gangue particles are heavier, no? Or the gangue particles are denser, no? So they are settled. Okay, mama. Okay, the powdered form of the ore along with this gangue is allowed to flow with the running flow of water. So during that time, the gangue particles, because of possessing lower specific gravity, they are washed away by the water, whereas the ore particles has higher specific gravity, they are settled. So again it's given here, the lighter gangue particles are washed away with the running water since they possess lower density. Is it clear, ma? Okay, and this method is mainly applicable for native ores. About native ores we have seen in the first video itself. Native ores example, gold. Okay, so it's mainly employed for native ores such as gold, and also for oxide ores such as Fe2O3, that is hematite or iron oxide, tin oxide, or it is called as tin stone. Is it clear, ma? So what are the important points we have seen from the gravity separation method? The ore particle and the gangue particles must possess a different specific gravity. Generally, the ores will have higher specific gravity, whereas the gangue particles will have low specific gravity. Now, the powdered form of the ore is allowed to flow with the running flow of tap water. So, during that time, the lighter gangue particles are washed away with the running water because they possess lower density. And this method is mainly applicable for native ores such as gold, and for oxide ores such as iron oxide, tin stone, and so on. Okay, so in the picture I have marked the parts. Part number 1 is running flow of water. Part number 2, this is the ore container. It contains the ore in the finely powdered form. Then point number 3, here the heavier ore particles. Then point number 4, lighter gangue particles. The lighter gangue particles are washed away, whereas the heavier ore particles are settled down. So clear, ma? So this is the method called gravity separation method. Okay, dear students, now let us see the second method of concentration of a ore, and this second method is froth flotation method. Okay, froth, the meaning of the term froth we all know, that is nurai. Okay, so this method, in the previous method, that is the gravity separation method, that is mainly applicable for the ores and the gangue particles which possess a different specific gravity values. And this method, this froth flotation method of concentration of ore, it is mainly applicable for sulfide ores. The examples for sulfide ores are given here. ZnS, that is zinc blending, and PbS, lead sulfide, or it is called as galena. Okay, so these two are the examples given for the sulfide ores, and this method, froth flotation method, is mainly applicable for the concentration of sulfide ores. It is a very, very important key point. Okay, this method is applicable for the concentration of sulfide ores such as zinc oxide, galena. Okay, Mama? Okay, and this is the flow chart showing the process employed in the froth flotation process. Okay, so what is given here? Crust ore. Crust ore means the powdered form of the ore. Okay, so the crust ore is taken. Along with the crust ore, water is mixed. Then pine oil. This pine oil is called as frothing agent. So because of the addition of this pine oil, what is generated? Froth is generated. Okay, so two different things we are adding: water and pine oil. So why this dissimilarity means? We know that ore particles are associated with the gangue. Okay, here one important condition is there. The ore particles must be wetted by oil. அதாவது ore particles oil-ஆல வெட்டாகணும், which means this oil can generate the froth of the metal. Okay, whereas the gangue particles should be wetted by water. So the gangue particles will remain with the water, whereas the metal particle remain with the pine oil. So that is why we are adding two dissimilar particles. One is water and the one more is oil. Okay, the gangue particles are wetted by water, whereas the ore particles are wetted by pine oil. Okay, and because of the addition of this pine oil, what is generated? Froth is generated. This is the froth of the metal which we are extracting. Okay, so water plus pine oil plus collector plus depressing agent. So these are the components needed for froth flotation process. What are they? Crushed form of the ore, that is finely powdered form of the ore, plus water. Okay, water is added for removing impurities. Then pine oil is added to generate the froth of the metal which we are extracting. Then collector and depressing agent. Okay, so the role of all these things I have written here. First, pine oil. Okay, what is the role of pine oil? It is acting as a frothing agent, which means this is the one which is responsible for the generation of the froth. Okay, then secondly, collector. Okay, here the role of collector particles is to make the ore water repellent. Okay, what is the role of collector? By adding this collector, the ore particle will become water repellent, which means the ore will not be reacting with the water. Instead, it can react only with the pine oil. So for that purpose, what is added? Collector is added. Okay, so the role of collector is to make the ore water repellent. In our case, the collector we have used is sodium ethyl xanthate. Okay, in the extraction of either zinc sulfide or in the extraction of galena, what is added as a collector? Sodium ethyl xanthate is added as a collector. What is the role of collector? To make the ore water repellent. Okay, Mama. Okay, the next one, depressing agent. So that we are going to see now. What is the role of depressing agent? Dear students, if you take the zinc sulfide ore, okay, we are getting it from the earth crust. So surely the zinc sulfide will not be in the pure form. It will be containing some other metal compounds. For example, zinc sulfide may contain a little amount of lead sulfide. Okay, but what is the metal we need to extract? We need to extract only zinc sulfide. So zinc sulfide may contain a small quantity of lead sulfide or some other impurities. Okay, so while the extraction, these other metal atoms should not come with the froth of the metal we are extracting. So to avoid that process, what is added? Depressing agent is added. Okay, the role of depressing agent is to prevent the other metals from coming to the froth. So that is the role of adding depressing agent. So clear, ma? These are the things we have used for froth flotation process: crushed ore, water, pine oil, collector, depressing agent. Okay, what is the role of pine oil? It is acting as a frothing agent. What is the role of collector? To make the ore water repellent. And what is the role of depressing agent? To prevent the other metals from coming to the froth. Okay, and in our case, the depressing agent we have used is sodium cyanide. Okay, Mama. Okay, so I think you may have a little idea about the froth flotation process. Now look at the diagram of froth flotation method. This is the diagram of froth flotation method. Okay, okay, so in a container, the crushed ore, the water, pine oil, collector, depressing agent, everything is taken in a container, and this is a stirrer na kalakki. Okay, so the stirrer is used. So while stirring this mixture, what is generated? Froth is generated. Okay, Mama. So this is the froth. The gangue particles will remain at the bottom, and froth is floated. It rises to the surface. That is why it's called as froth flotation process. The froth is generated and it comes to the surface. So it's called as froth flotation process. And this froth will contain the metal. ஓகேவா, இந்த ஃப்ரோத்தில் தான் நமக்கு தேவையான மெட்டல் இருக்கும். ஸோ இதை நம்ம எக்ஸ்ட்ராக்ட் பண்ணி அதிலிருந்து நமக்கு தேவையான மெட்டலை நம்ம பியூரிஃபை பண்ணிக்கலாம். ஓகேவாமா? ஓகே, ஸோ திஸ் இஸ் த மெத்தட் ஆஃப் froth flotation. Okay, let us see now. See the processing. When this mixture is agitated using the stirrer, by using a stirrer, you are agitating this mixture, the mixture of crushed ore, water, pine oil, collector, and depressing agent. So while agitation, what is generated? Froth is generated, and the froth, it rises to the surface. It is floating on the surface, and so it's called as froth flotation. Okay, now the metal which we need to extract is present in the froth. So this froth is skimmed off, which means it is separated, it is dried, and the concentrated ore is recovered. From the froth, what is recovered? The ore is recovered. Now from the ore, by doing various processes, we can extract the metal. Okay, Mama? Okay. This point already we have seen. When zinc sulfide impurity is present in lead sulfide, if you are extracting lead sulfide, it contains a small quantity of zinc sulfide. Okay, what we are extracting? Lead sulfide. It is containing a small quantity of zinc sulfide. So this zinc should not come with the froth. Okay, so to avoid that, what is added? Sodium cyanide is added, and the role of sodium cyanide is depressing agent. Okay, this separately can be asked in a 2-mark question. What is the role of adding sodium cyanide in the extraction of lead sulfide? So what is the role of adding sodium cyanide? It is acting as a depressing agent. Okay, Mama, is it clear? Yes. So shall we see one more time the processing of froth flotation? Yes. Okay, it is mainly applicable for sulfide ores. Example, zinc sulfide and PBS. PBS is galena. This is the processing. The crushed ore is mixed with water, pine oil, collector and depressing agent. What is the role of pine oil? It is acting as a frothing agent. What is the role of collector? To make the ore water repellent. What is the role of depressing agent? It is to prevent the other metals from coming to the froth. Okay. When the mixture is agitated using a stirrer, what is generated? Froth is generated and the froth rises to the surface of the container. Now the froth is skimmed off, dried, and the concentrated ore is recovered. Okay. To avoid the other metal sulfides from coming to the froth, what is added? Depressing agent is added. In the extraction of lead sulfide, to prevent the zinc sulfide from coming to the froth, what is added? Sodium cyanide is added as a depressing agent. Okay, Mama. So in this video, we have seen 2 concentration processes. What are they? One is gravity separation and the one more is froth flotation. And the remaining 2 techniques we will see in the coming video. Thank you.